I'm using a different drawing tablet here.
So I have this kind of like a worksheet, but not really.
Are they problems you can verbalize?
Yeah.
Just go ahead and start wherever you like, and I'll write it out.
Well, I can't really do all of these. Let me see if I have something challenging.
Okay.
I'll probably do like next week's homework.
Okay. Yeah, it's definitely an advantage to get a little ahead of the game. I mean, if you know how to do all of the ones you're looking at right now, we shouldn't waste our time doing them. But if we can get you a little bit ahead, then you'll be all the more prepared when you encounter the material for next week.
Yeah.
Although make sure you can do all the ones you're looking at for this week. In other words, the first 10 might look easy, but then they might get a little harder.
Yeah. I have one thing to do, and then I can just probably like look at some random problems.
Okay.
Alright, so you need to write a table.
I need what?
I might just send it to you.
Okay, go ahead, do that.
Should I take a picture?
Yeah. Have you sent stuff to me ever?
No.
Well, send it to this email. Don't send it to my phone.
Okay.
Because I can't do anything with it on my phone.
Yeah.
Send it to this email, and once you send one thing, it'll record it, and you won't have to type the whole thing out every time. Send it to that. And holler when you've sent it.
@gmail.com.
Yes. And are you using an iPhone?
Yeah.
Send it as a large file attachment. That's the best way to do it. There's a variety of ways I'll be able to read it, but if I need to rotate it or zoom in or zoom out, it's better if you send it as a file attachment, which I can download, and then I can do whatever I need to do to it so that we can look at it. If you send it,
I already sent that one thing.
okay, well, let's see how it comes in. Has it said sent yet?
Yeah, it has.
Did you send it to David Cowan, spelled exactly like this with the 1949 after the end, no spaces?
1949, yeah, it's just like that.
Sometimes it'll take 15 seconds to come in. How many pictures did you attach? Just one?
Hold up.
If you attach a lot of pictures, it's going to take a long time to send. It's like exponential. One picture might take 10 seconds. 5 pictures might take 2 minutes.
So you want me to send it as a large?
Large image. Attached file. In other words, attach that file to the email as a large image. Small image definitely will not work. By the time I blow it up, we can't read it. The resolution isn't good enough. But a large image is beautiful. Okay. You're not getting any messages back saying could not send to that email address or anything, are you?
No, I didn't. I'll look at the thing I just done.
Well, I tell you what, why don't you try describing it, and we'll wait and see if it gets here eventually. But rather than sitting on our thumbs waiting for it, let's go ahead and try to do it.
Hold on a second. I almost got it.
Okay.
I know that did this time. Is it coward 19? 49.
It should be so that when you type the first 2 letters, DA, it should give you a list of default emails, and mine should be on there now.
Oh, it did.
It did. Okay, good. And that's great, because the next time you need to send something, you won't have to type out that full email.
Yeah, I got it.
Okay. There it is. Creative Arts, is that you?
Yeah.
All right. All right. Now, that is not an attachment. I can still handle it. Maybe I can download it. Hold on. Let me. Oh, yes, I can still download it. Excuse me. That is an attachment. Let me go ahead and download it, and then I'll open it up. Must be because it's a JPEG file.
Yeah.
Oh, boy. Gives me all these options. I guess I'll open it as a photo. All right. Is that everything?
Yep.
Okay, cool. All right, what kind of calculator do you have, Nick?
Just a regular calculator.
So when they ask question B, what's the equation? They just want you to estimate an equation? Because if you had a TI-84,
I mean, I am doing homework for next week, so that might be why. Because I don't have anything to do right now.
oh, well, it still might matter. In other words, well, let's do this problem. Let's go ahead and do this one problem at least. Hold on, let me get a new page open here and take this to the right far enough that I can draw a grid. Here's my X and Y axis. Okay.
Okay.
What's going to be on the X axis? Study hours or grade?
On hours.
Okay. So we'll even label that hours. We'll label this grade. And I don't have to, I mean, they gave you a grid so you could be exact, but the truth, yeah, I'll label this. Let's see, that I got to go up to 4, so that'll be 1, that'll be 2, that'll be 3, and that'll be 4. My grades go from 60 on the low end, I'll call that 60, to 92 on the high end. A little break down there, you see? That's kind of what that means, is that it's I'm ignoring from 0 to 60.
Yeah.
Because I don't want to make all that space that I'm not needing. So now we just plot each of these points. 3 goes with 84. So I'm going to plot that point right about there. 2 goes with 77. 77 is about almost exactly halfway between 60 and 92. So I'll call that 77.
Okay.
I need 5 hours. I didn't see that 5. 5 hours, I'm at 92.
Okay.
1 hour, I'm at 70. 0 hours, I'm at 60.
Yeah.
4 hours, I'm at 90.
Yeah.
And 3 hours, I got another one at 3 hours that's 75. Oh, let's see, my first 3 hours was 84, so this one has to be below the second. Got to be right there. Okay, so there's my scatter diagram. Now, draw in the line of best fit. Well, I'm going to do it in red. And what I'm attempting to do, it's not necessarily going to go from this far left point to the far right point.
Okay.
Might. I mean, I could try that. We'll see what it looks like. It's going to be a straight line. Something like that. Okay. But it also could be maybe something that looks a little bit more like that.
All right.
Now, mathematically, the way they come up with the line that represents the best fit is they take the distance from each dot to the line. We'll assume the green line is a better fit, okay?
Okay.
We sum up that distance, the perpendicular distance to the line, square them all, add them up. Whichever line ends up in the smallest number, that's the line we want to use. And you can see that that green line is actually quite a bit of ways from some of those dots. The red line, on the other hand, if I look at the red line, boy, that's a real tiny distance there. That's a pretty tiny distance there. That's a pretty good distance. That's a tiny distance. That's right on. So clearly the red line in this example is going to be a better fit than the green. So let's erase the green. You don't do these by hand, though. You do them in a calculator. But you have to have a calculator that'll do them. In other words, a regular, desktop calculator, a non-graphing calculator probably won't do it. But if you have at least a TI-83, then what you do is you make two lists, and then you ask it to give you the equation of the line of best fit. And it will spit out an equation that's the equation of that pink line or something close to it. I don't know what it is for this scatter diagram. In other words, it's extremely difficult to come up with the line of best fit manually. You just can't hardly do it because that line could have, slightly different slope and maybe be a little bit better fit if I change the slope of it just fractionally. Well, the computer knows how to do it, or the calculator. And so when you feed in these two lists, list 1 being the study hours, list 2 being the grades. Have you ever put in lists into a calculator before?
No.
Surely if this is next week's homework, they're going to talk to you about that, and they'll tell you how to do it. Once you have your two lists, now you can request the line of best fit. And what it basically gives you back is the line in y equal mx plus b format. Well, we could estimate that line. What's b?
Would be
the y-intercept. Remember, when you're in y equal mx plus b format, m is slope, b is the y-intercept. Well, we can see the y-intercept is 60.
Yeah.
What's the slope? Rise over run. Figure out what rise over run is. Well, if I was going to figure out rise over run, the rise, I would take the difference between 92 and 60.
Yeah.
And the run is from 0 to 5. So the rise over run is 32 divided by 5 times x. So there is a pretty good guess for the equation of that pink line. So if this is not a calculator problem, this is the way you would do it. You would draw your scatter diagram, you would draw the best line you could through it, and wherever it crosses the y-axis, that's your b. Whatever the slope is, always remember slope is rise over run. Now, I could have done the distance between this point and this point. Let me point with my cursor. I could have done the distance between this point and this point divided by 1. In other words, that rise, what I'm trying to say here is the distance between there, and of course the run is 1. So what was that point? That point was 77, so 77 minus 60, that's 17. That's pretty close to what we got. We got 15 and change.
Yeah.
The point is that the greater the run, the more accurate your slope's going to be. I didn't want to choose 2 points that were right next to one another. I chose the 2 points that were furthest apart on the x-axis. And that's 0 hours and 5 hours.
Yeah.
And so I took the rise between those 2 points. That's what was 32, and the run was 5. Okay? So if he just wants you to estimate the equation for the line of best fit, that works right there. And now you can answer the rest of them. In other words, once we have an equation that represents this problem, predict the grade for a student who studies 6 hours.
Yeah.
What is the grade going to be?
What is the worst time?
Well, plug in 6 for x. In other words, this equation, y is your grade, x is the number of hours you spend studying.
Okay.
So plug in 6 for x, what do you get for a grade?
You receive is it 80? No, it's not that.
Got to be bigger than 92, doesn't it?
Yeah.
The slope of this line's going up. So if I'm going over 1 more hour on the horizontal axis, I'm going up more on the vertical axis.
Yeah.
Just plug in 6 for x and do the math. Do you have your calculator in front of you?
Do I have my calculator in front of me?
Uh-huh.
Yeah, I do now.
Okay, you need to have your calculator when we do our sessions. Because
yeah, I mean,
better that you do it on your calculator than me doing it. You don't learn anything when I do it. 32 divided by 5 times 6 is equal to 38.4 plus 60. So 6 hours would give you,
98.4.
yeah. What would you get if you studied 20 hours?
Plug in 20 for x.
Not quite. Think about it. What's the maximum grade you can get?
100.
Yeah. So this curve is only linear up until a certain point. In other words, if I draw this thing entirely out, well, gosh, at the end of 6 hours, I'm already at 98.4, which is right there. So in reality, the curve might do something like that. In other words, beyond a certain number of hours, you're not going to increase your grade any.
Yeah.
It's going to stay at 98.4. You may get it up to 100. You're never getting it above 100. But in other words, there's kind of a point of diminishing returns where every hour extra after 6 does not necessarily increase your grade by 6 points. But between 0 and 5 hours, it's pretty linear. And I agree totally with that. I have students that do 2 hours a week, and I have students that do 1 hour a week. I guarantee the ones that do 2 hours a week do a little bit better, just because 2 hours is more than 1 hour. So anyway, that's what they're talking about there. And let's see. I wasn't looking at question D when I asked that question, but could this line go on forever? And obviously the answer is no.
Yeah.
The line can go on forever, like I've drawn it, but not as a straight line. It's going to have to start curving or have a bend in it, like I've got.
Yeah.
And the explanation, why or why not, because your grade cannot be more than 100.
Well, that's all the homework that I have.
Okay. Do they demand that you have a graphing calculator? I'm curious. Usually they do.
I mean, I've seen them have like big cases of them, so I'm pretty sure they'll supply them.
Really? That's unusual. What school do you go to?
Ralston Valley.
I got a lot of Ralston Valley students. I don't know any of them that get calculators supplied by the school. Most school systems will tell you when you start high school that you have to have a graphing calculator. In fact, most of them now demand that you have an Inspire, a Texas Instruments Inspire as the graphing calculator.
I know my sister has one of those, but she's using it and her friends right now, so I don't have
Right. That's fine. And you wouldn't be able to use hers in class anyway because she's going to need it in class.
Exactly.
The higher up you go in math, the more you need that calculator, trust me. This is probably the very first type of problem where you would need a graphing calculator. In other words, this is not a problem you can solve manually. There probably is a way to solve it, but I don't know what it is, and it's complicated, and it would probably take a full hour to solve it if you knew how to do it manually. And he's never going to expect you to do it manually. He's always going to either expect you to do it the way we did it, which was a guess, or to use your graphing calculator to come up with the exact line of best fit.
Okay.
And if you did put that list into a graphing calculator and came up with a line, the only numbers it's going to give you are M and B. In other words, it's going to give you an answer like M equals 17.3 and B equals 59. And it's up to you to translate that back into Y equal MX plus B format. But the calculator gives you M and B only. Then you would have your exact equation and you could answer the question C. What grade does he get when he studies 6 hours? Okay. All right. So you just want to do a half hour tonight?
Yeah, that sounds good.
All right. I will talk to you next Wednesday, Nick.
Sounds good.
All right. Bye-bye.